video because we're going to talk a little bit about things we did last year. And I always find it kind of cool when we can connect things from one year to another year. And you can see that what we're doing here is not just a kind of separate weird topics that have nothing to do with each other, but you see how things connect and build in math. So we have to figure out, we talk about even odd identities. However, now we need to figure out which ones are even and which ones are odd. And what does that really mean? And right away when I think of even and odd, I remember last year and I remember polynomial functions. Polynomial functions. And you can still be like, what are you talking about? But you guys remember those little guys, like the little guys like that? And we used to do the polynomial dance. Their hands can be in the air up, or their hands can be in the air going down in an even function. And if we have an odd function, one hand was up and one was down, or the other way around. We were doing what we call the polynomial dance. Okay, let's add some feet to these guys, otherwise they look weird. Okay, and if you remember an even polynomial function, for example, I'll give you an example of one, is x squared. So it has its leading term has a variable raised to an even power, and for an odd one, the leading term's variable was raised to an odd power. And how does that affect the function? Well, in this case, if I substitute x with a positive number, right, a positive 3, so I have f of 3, I'm gonna get 3 to the second power, sorry. I'm getting 3 to the second power, which equals 9. And then if I plug in the same but the negative number, I get negative 3 to the second power. Well, that's still 9. So my output is really the same. So for a positive, if this is a coordinate plane over here, a positive 3 gives me an output of 9, and a negative 3 also gives me an output of 9. That's why my function points in the same direction, right? Sometimes I may have a different function. I may have f of x is equal to minus x squared. The minus is not raised to the second power. Then if this is function 1, this is function 2. If I do function 2, I get f of 3 is equal to minus 3 to the second power, which the minus stays as negative 9. Or if I have a negative 3 over here, I have minus 3 to the second power, which again is negative 9. So I again get the same output. Okay, so this is what's interesting about these functions. If I have f of x, I always know is going to be equal to f of x. But if I put a negative number in, a negative x, I'm still going to get the same output, f of x. Right? I put in a 3 and I get a 9. I put in a negative 3, I still get a 9. I put in a 3, I get a negative 9. I put in a negative 3 and I still get a negative 9. So those are two different functions, right? And those two different functions always give me the same answer. So no matter if I put a positive or a negative, I always am getting f of x out. What's going on with the odd functions? Well, let's give some examples. Example number 1 is over here. So if I do that, if I plug in 3 over here, I get 3 to the third power, which is 27. But if I put a negative 3, now negative 3 to the third power, I have 3 minuses. I have minus and minus, 3 minuses. The first 3 minuses are going to make a plus, but then the plus and the next minus are still going to keep a minus. So what is going to happen is that I'm going to have a negative 27. So if this is my coordinate plane, and this here is positive 27, this over here is going to be negative 27. Okay, so, and it's the same if I have f of x equals negative x to the third power. That's a different type of function. In this case, if I put in 3, I guess minus 3 to the third power, which is negative 27. And if I put negative 3 in, I get minus 3 to the third power, which gives me a positive 27. So again, if I put a positive 3, I get a negative 27. If I put a negative 3, I get a positive 27. So, what does that really mean? F of x obviously is equal to f of x, but if I put a negative number in, am I gonna get f of x? Here I got a 3 and I put a negative in, I didn't get 27, I got minus 27. Here I had a 3 and I got negative 27, and when I put a negative number in, I didn't get a negative 27, I got the opposite, which was a positive 27. So this is what you always get with an odd function. Now, your job is to figure out whether cosecant of minus x, tangent of minus x, all those functions, even odd functions from the table in your activity guide, I want you now to figure out if they're even or if they're odd. Again, if you it doesn't matter what you input in an even function, it will always give you the same answer, no matter if the number you input is negative or positive. However, in an odd function, if you input a negative number or a positive number, you'll get the same absolute value out, but with a different sign. Now, here's a hint. Here's what you could do. You could just plug in some numbers, use the calculator, and try to figure it that way. Or you can just try to do some algebra. It's up to you what's the easiest way for you to do it.